All right, let's say we want to record the position of an object over a period of time. One great way to do this would be to make a graph of position versus time. So let's take this car, and we're going to go ahead and get it moving. And then as soon as it crosses x equals 2, we're going to start making our graph. So let's see what this would look like. Okay, here's our car moving, ready, go. And it's going to keep moving forward until it gets to 8, and then it's going to stay still, and then it's going to move backwards until it gets to -4, and then that's going to be the end of our motion. So, what would this look like on a position versus time graph? So we started our graph right as the object reached x equals 2. So at time equals 0, it was at x equals 2. And for the first 2 seconds, so this is 2, 4, 6. For the first 2 seconds, it was moving forward, and it kept moving forward until it got to 8 meters. So this is 2, 4, 6, 8 meters. So right here is 8 meters. And when we got to 2 seconds, we had reached a position of 8 meters. And it was moving at a constant speed, so this would be a nice straight line. Now for the next 2 seconds, it stayed still at 8 meters. So by the time we get to 4 seconds, it was still at 8 meters. So that means it had to slow down and stop and stay there at 8 meters. And then during the next 2 seconds, it went backwards from +8 all the way back to -4 meters. So it reached -4 meters here at 6 seconds. So in order to do that, it had to speed up again. But now it's going backwards until it got to the -4 meters, and that's when we stopped collecting data. That's when we stopped making our graph. Okay, so here is a position versus time graph for the motion of that car during those 6 seconds. Let's see if we can see that again. Starting now, we took 2 seconds to reach 8 meters, then it stayed there for 2 seconds, and then it took 2 seconds to get back to -4 meters. Okay, so let's take a look at this graph and see what we can learn from it. So for example, we can look at a graph to find the position of the object at any particular moment in time. For example, what was the position at 3 seconds? Well, to find the position at 3 seconds, we will start at 3 seconds. We'll come up to the graph, and we'll see that it was at 8 meters. Okay, well, what was the position at 1 second? Well, we start at 1 second, we come up to the graph, and we can come over here and see that it was at about 6 meters. Okay, so to get the position of the object, all we have to do is get that directly from the graph. Okay, what about displacement? Now, displacement requires a starting time and a stopping time. So for example, if I wanted to know the displacement from 2 seconds to 4 seconds, I'd say, okay, well, that means that this is my initial and this is my final, and the displacement would be 0 because the final position minus the initial position is 0. If I wanted to know the displacement from 0 seconds to 4 seconds, if I wanted to know from 0 to 4 seconds, my final position would still be 8 meters, but my initial position would be 2 meters, so 8 minus 2 would be 6 meters. So our displacement, we're going to basically read the graph twice. We're going to read the graph to find the final position. We're going to read the graph to find the initial position, and then we can find the displacement by x final minus x initial. Okay, what about average velocity? To find average velocity, we're just going to do x final minus x initial divided by time. So again, we're going to read the graph twice, and then we're going to divide by the change in time. All right, well, what about instantaneous velocity? So if I wanted to know the velocity at, for example, 5 seconds. Well, to find the velocity at 5 seconds, the first thing I need to do is find the point on the graph. So there's 5 seconds right there. The next thing I need to do is figure out, okay, what is the slope of the line? What is the slope of the graph here? Because remember that velocity is the derivative of position, and derivative is the slope of the graph. Okay, so if the velocity is the derivative of the position, and I want the slope of the graph, I need to find that this is roughly a straight line. So I need to find 2 points on that line so that I can find the slope. All right, so the 2 points on that line, I'm going to choose this point and this point. So the rise of that line is going to be negative 12 meters, and the run of that line is going to be 2 seconds, so minus 6 meters per second. Okay, what about acceleration? Well, let's see, we can do average acceleration. To find the average acceleration, we need to do v final minus v initial divided by delta t. So maybe I could find the velocity at 5 seconds, I could find the velocity at 1 second, and I could find the average acceleration from 1 second to 5 seconds. Remember, displacement, average velocity, and average acceleration always have a start time and a finish time. Whereas the position is right now, the velocity is right now, and acceleration is right now. So how do we find acceleration on a position graph? Well, actually, it's really hard because acceleration only happens when the slope is changing. Okay? So because acceleration is how quickly the velocity is changing. So that happens when the slope of the line is changing, which means that for this whole straight line, the acceleration is 0. And for this whole straight line, the acceleration is 0. And for this whole straight line, the acceleration is 0. So where's the acceleration not 0? The acceleration was not 0 in the places where the slope was changing. And in this case, both of these have a decreasing slope. We went from positive to 0, so the slope was decreasing, so that's a negative acceleration. And we went from 0 to negative, so again, the slope was decreasing, so that's also a negative acceleration. So I can't figure out how big the acceleration is, but I can see that the acceleration is negative, and we see acceleration on a position graph by looking at the curvature of the graph. So if I had a position graph where the slope increased and then decreased and then increased again, in the places where the slope is changing, that's where we have acceleration, and this would be a positive acceleration because the slope is increasing. This would be a negative acceleration because the slope is decreasing, and this would be a positive acceleration because the slope is increasing. All right, that is it for position.